Hello students, welcome to chemistry class. This is the online class series for chemistry. This is the part 1 of this series. The class is presented by your chemistry teacher Mohit Alfred. Dear students, you have to follow your regular textbook. This is Essential ICSE Chemistry for class 7 by Bharati Bhavan Publications. Let us begin. What we'll be beginning from is chapter number 1, matter and its composition. What we are going to learn, let us have a look at the important topics. First we will see here is matter and its composition. What is matter? What is actually matter? What it is made up of? Then we will see the different forms of matter or states of matter and what is the difference, what is the reason for difference in those forms of matter. Then we will see individual properties of matter. We will see shape and volume, compressibility, fluidity and thermal expansion. Followed by this, we will see the change in the state of matter, how this change is taking place. Last but not the least, we will see the composition of matter, what actually is composing there, what this matter is made up of is atoms and molecules. How these atoms and molecules constitute matter, that will be seen in the last part of this chapter. Let us begin. The first topic here is what is matter. Dear students, you have been introduced to matter in class 6th as well. So this I will not go into much deep details, just let us have a look at the definition here. Anything that occupies a space and has mass is called as matter. Anything that can be food you eat, the water you drink, the air you breathe, air should be air, I missed in typing, the air we breathe, the clothes we wear, everything around us is made up of matter. Each and everything is made up of matter. Let us come to the next slide. All the are reading parts, you can read from the textbook as well. Mass and volume. Now when we talk about the definition of matter, anything that occupies space and has mass is matter. Now two terms are coming repeatedly when we are talking about this definition of matter. So why does it matter in the definition of matter? Why is it so important? Let us have a look on these terms one by one. The definition says the space anything occupies is called as volume. For example, the space a football occupies is greater than the space a tennis ball occupies. Football is bigger than a tennis ball, so football will take more space. The more space is taken by some substance, that we can say it is having more volume. If some substance is taking less space, then that means it is having lesser volume. The next thing regarding mass, the amount of matter, how much matter is contained in any substance, that is called as mass. That is, what is mass is contained is about the amount, related to the amount of matter, how much matter forms a particular object. So if the mass of some substance is increasing, its weight is also increasing. For example, you can see a glass full of water and half glass of water. So as it is obvious, glass full of water is containing more mass. Obviously it will have more matter than the half a glass of water. Let us come to the next slide. Let us have an activity to show to prove these points of mass and volume regarding matter. We can take a ruler, and you can see the diagram over here. You take a ruler or a wooden stick, put a string in between and tie two balloons. You can inflate the balloons with air, or you can take deflated balloons also. Here in the diagram you can see two inflated balloons are taken. If we take two inflated balloons and tie on the two ends of the ruler there, you can see it is perfectly balanced. None of the sides is going upside or downside. But if you pinch a balloon with a pin, then what will happen? That will burst. And here you can see there, one of the side has gone down, another side has gone up. That means what? That means air that was filled inside the balloon, air containing the that was filled inside the balloon, it was having some mass. That is why this difference of mass or weight has shown this kind of disturbance in the balance. Also, another thing you can see here, this deflated balloon. This deflated balloon is taking less space compared to the inflated balloon. That means air occupies some space also. By this small activity, we can prove that air is also made up of matter. So this is the activity that proves that air is made up of matter and it occupies space, and also it has some mass or weight. Let us move to the next topic, that is states of matter. You know that when heated, a cube of ice melts into water and the water evaporates into water vapor. This is a common observation. If we take ice, it will melt into water and water converts into water vapor. On the contrary, also opposites can be observed. That is, water vapor converts to water and water converts to ice. That means the same substance is forming from one form to another. That is why we can conclude that matter exists in three forms, that it can be solid, it can be liquid and gases. That are the three forms or states of matter. Now if three forms of matter are there, the question arises, what is the reason for this difference of states of matter? Water can exist in three forms: ice as solid, water as liquid, water vapor in the gaseous form. But what is the reason for difference? Let us understand actually what this matter is made up of. The line here is important. Matter is not continuous. It is not continuous means what? It is not regular, or we can say anything or any substance or matter is not made up of a single substance or a single entity. It is made up of what? Matter is made up of small particles. Yes, students, matter contains smaller particles. For example, for an ice cube will have different water molecules joined together, and that will form a ice cube. All different water molecules will join up together and they will form one bigger form of ice block. So different smaller molecules are joining together, and what is formed is called as matter. So matter is formed of what? Matter is made up of small particles. It is not made up of single particle. Matter is made up of different smaller particles, and those smaller particles are called as molecules. And when the molecules are arranged together, they are joining together, there may be some space between them, between two different types of molecules. One molecule is here, another molecule is this side, and there may be some space between them. That space which is between them, that is called as intermolecular space. Whatever space is there between two different types of molecules, that is called as intermolecular space. Also, if there is a space between different molecules in the matter, there may be some sort of attraction, otherwise the molecules will go away from each other. Why the molecules are held at their place? Why they are not changing their place? That is related to the force of attraction there. That is related to force of attraction. We will read this line. The molecules are held together by the force of attraction. That force of attraction is called as intermolecular force of attraction or cohesion. Yes, students, you remember both these definitions are important. You can mark in your textbook as well, wherever this colored fonts I have given there, all those are important terms. You have to mark or underline and revise at the time of exam as well. So intermolecular force and intermolecular space, both the definitions you should be clear with. So intermolecular space is the space between different molecules, and intermolecular force of attraction or cohesion is the force of attraction among or between the different molecules in matter. Now here is an important relationship. This is very important. That is between this relationship is between intermolecular space and intermolecular force of attraction. Greater the cohesion, let us read there. Greater the cohesion, the first point I am reading. Greater the cohesion, the smaller is the intermolecular space. Yes, students, like in the ice block, what is happening? Different molecules are tightly packed. All the molecules are closely linked to each other. So then what will be happening? The space between the molecules, there will not be any, in between the molecules there will not be any space. So less space will be there if more force of attraction is there. What I said, if more cohesion is there. More cohesion means what? It means less space. More cohesion, less space. Its opposite we can write, less cohesion or less force of attraction. Then what will happen? Then it will lead to more space. More space is where? More spaces in case of gases. Maximum spaces in the case of gases. Gases molecules are, and they can be anywhere. All are simply moving here and there. They are not following any order. Randomly the molecules are moving in different. One will go in any direction. Anyone can go. Everyone is free to move in any direction. So in the gaseous molecules, what is happening? The molecules are having maximum intermolecular space. Why they are having maximum space? Because there is very minimum. There is minimum force of attraction or cohesion. Because attraction is not there, the molecules are not coming close to each other. So this both these lines you will remember. These are very important facts. Let us come to the next line. For any substance, intermolecular space is minimum. Minimum space is in the case of solid state, then followed by liquid state, and maximum or largest intermolecular space is in gaseous state. Its opposite will follow for in the case of attraction. There the molecules are tightly held. They are tightly packed or closely held together in case of solid state, followed by liquid, followed by gaseous state. In the gaseous, as I told, molecules are free to move. Let us come now and understand the different physical properties after having been discussed the different reasons. These were the reasons why the difference in state of matter is there. Why ice and water vapor are behaving differently. All are formed of H2O only. Ice is also H2O. Water vapor is also H2O. Then why this H2O in ice is tightly packed and why this H2O in water vapor is loosely packed? That is related to intermolecular force and intermolecular space. I hope it is clear. We will now move to the next topic, that is physical properties of solid, liquid and gas. Dear students, in our textbook these 4 important properties are given. Today in the present class we will be dealing with the first 3. The next topic onwards we will deal in the part 2 of this lecture. So today we will be learning shape and volume, then compressibility and fluidity. The first physical property of solids, liquids and gases that we will be studying is shape and volume. Let us see for solids. A solid has a fixed shape and fixed volume. It is related to the aspect or the principles of intermolecular force of attraction and intermolecular space. Just now we have learned that in solids the intermolecular force of attraction is maximum. As a result, what will happen? The molecules of the solid will be tightly packed. They will be closely attached to each other and it gives a fixed shape to the solid. And because the shape is fixed, what will happen? The volume or the space occupied by the solid will also become fixed. These are the 2 things regarding shape and volume for solids. As a result of this fixed shape and fixed volume, what is happening? The solids become very hard. They are generally hard. All the solid objects are generally hard. Here the reason is written. You can read there. This is so because the molecules are tightly held and they cannot move close or away from their positions. Let us move to the second point, that is regarding liquid. A liquid has fixed volume. Any liquid will take a limited space based on the quantity of the liquid. The volume or the space occupied by the liquid does not change, but the shape changes. Yes, the shape changes. You can see the photograph there. Liquid has been poured into different kind of containers, and you can see the liquid shape is according to the shape of the container. So the liquid takes the shape of the container. Why is it happening is that the molecules are not so tightly held as in the solid. In the molecules of the solid, we can say their molecules are tightly packed. They cannot even move from one place to another. But in the case of liquid, they can be moving little bit, not so freely as in gas, but they can move little bit and change their position. As a result, we can say the shape of the liquid can be changed. So here it is given, they can slip over one another and they stop where the molecules of liquid will stop at the surface of container and take the shape of take the shape of the container. Let us come to the next one, that is the gases. The gas has neither fixed volume, it is not having fixed volume, and also not having fixed shape. Why is it so? The reason is simple, because there is no or very minimum force of attraction. Intermolecular force of attraction is very much minimum there. Let us see here one photograph I have taken. I will zoom in for you. Here you can see both all these properties are shown. First one is solid. It is neither taking the shape of the container, and also it is actually tightly paired. The molecules are closely attached to each other. Here the molecules are little bit free, so they are moving from each other, away from each other, and where they are stopping on the walls of the container. As a result, they occupy the shape of the container. In the last, the gas molecules are freely moving and they will occupy full container. Actually, the bigger the container, they will spread in full container. If you spray, if you use some a perfume bottle, for example, you spray some perfume in one corner of the room, the full room will get the aroma or the smell. Why is it happening? Because the molecules that were in that gas, in that perfume, they will take or occupy the space of the full room. If any leakage is there in LPG, you can easily identify that, because that gas is spreading fastly. The molecules are spreading from one place to another. That is because of the intermolecular force of attraction is very less there. So the gas is not having fixed volume, also it is not having any fixed shape. I hope the aspect of shape and volume is clear to you. You will remember these points which I have given in color there, in the colored form there. The reason also you have to remember. Next one, now the next physical property is compressibility. Compressibility means, can we press any form or the state of matter or not, or to how much extent we can compress it. Here the photograph or the diagram is given there. First one shows the solid, second one shows the gas. Now, as in the solid, the molecules are tightly paired, and if we try to compress it, if we try to put pressure on this from upwards and try to push it downwards, then it will not, and then we cannot compress it. The molecules will not change their position, because there is no space in between the molecules. Where the molecule will go, it needs some space to move, but there is no space to change the position. As a result, in the solids, we can say the solids are practically non-compressible. Then liquid, little bit space is there, so they are also compressible to a little extent. That depends on how much space is available for the molecules to shift from one place to another. In the case of gases, you can see in the diagram as well, the gases are compressible to a very great extent. We can easily compress the gas. The reason also, as I already explained, you can read in here if you want. You can pause the video and read. Also the textbook also same thing is written. I already have explained, so without reading there again, we will move to the next physical property, that is fluidity. Fluidity means ability to flow. What fluidity means is ability. This is the ability to flow. So solids can flow. The answer is obviously no. Liquids can flow. Yes, the liquids can flow. The gases, yes, gases also flow. The example of perfume I told, that aroma is spread in the full room, so that is also able to flow. So liquids as well as gases can flow. Why they can flow? Because the answer is because of the less force of attraction in case of liquids and gases. Liquids flow slowly because some force of attraction is there, but gases flow very fastly because least force of attraction is there. Let us read here what is written. solids do not flow, but liquids and gases do. So if we are asking that liquids and gases are fluids, you will remember liquids and gases are fluids. Then you will also always reply yes, liquids and gases are fluids. You can ask, like for example, we can ask true and false. That we can ask a solid is a fluid, answer will be false, and so on. So I hope it is clear. What is the reason is because the cohesion or the force of attraction, intermolecular force of attraction, is very strong in solids but not in liquids and gases. So here this line you will mark in your book, underline that is liquids and gases are fluids. Now one important aspect of gases is there. Whenever gases are flowing from one region to another region, they are always flowing from high pressure zone or high pressure area to low pressure area. What is this high pressure area? High pressure area is that, let me zoom in here. There you see now, high pressure area is that kind of region where the molecules are compressed, and the low pressure area the molecules are not compressed or compressed to a little extent. So the gas molecules always move from high pressure area to a lower pressure area. They will never move from low pressure area to high. Always the gas molecules move from high pressure area to a low pressure area, because the gases have a tendency to remain free, and if they are tightly bound, they are compressed by something, they are pressurized by something, they will try to leave that atmosphere of pressure and they will move in a atmosphere where they can be free. Gases are having this natural tendency to remain free flowing. They cannot remain compressed. So always what will happen, the gases will flow from the high pressure zone to a low pressure zone. So students, now I will wind up this lecture for today, and I expect and instruct you all to kindly read and revise from your textbook. Whatever is being told in the online class, you have to read after viewing this online video. And you have to read not only chemistry, but you have to read all your textbook, all your subjects book, and keep revising and keep learning. Regarding any doubt, you can write in the comment section below in this video.